All right, so now that we know how to tell how many, if a point is a solution, we have to talk about how many types of solution there are when graphing two equations. So we've got the option of one solution. This is if the slope, solution, the slope is different in both lines in any way, and they'll cross at a single point, like that. Okay, and that would be the one solution to the system. So just like on these points that they ended up working out nicely for that, this ends up working nicely for us, for one solution. Now there's also the option of no solution. This is when they have the exact same slope. These lines are called parallel. Okay, so this would look like this. So we've got that line. Oh, let's pretend I drew that correctly. And that line. So these two lines are parallel. They are the same distance apart the whole way, if I drew it correctly. I might not have, so forgive me if I didn't. So those are parallel lines. They never ever touch, ever. They never intersect. And now I've erased that line. That's so great. Okay, and then there are infinite solutions. Okay, this is because if I have this line, it's when they're the same line. And then I have this line that's on top of it, they share all their points in common. So my hint here is they're the same line. Okay? All right. So with that information in mind, we are now just going to be going through and graphing some systems. So first off, we need to go over the steps for graphing. So we need to solve both equations so they are y equals mx plus b. If they're not, it's going to screw you up. Then start at the y-intercept, which is the b. Remember the b is the number without the x. Okay, then you're going to move the slope, which is rise over run, to complete the line. Look for the solution to the system, which is the intersection of the two lines. So we're going to practice this one. Currently, they are both already solved for y, which is beautiful. Okay, so we're going to start at the b for this first one. I'm going to make it green. So we've got -3. So I'm going to go to -3 on my y line. And then I have a slope, and it's invisible right now. It's 1 over 1. So I go up 1 over 1. And I can continue that pattern forever. If I wanted to go backwards, I'd go down 1, left 1. Okay. We connect our dots. There's our graph for that first line. So the second line, notice that this is going to be a -1 over 1 slope. And we're going to start here on -1. So we're going to go to -1. This one has a -1 over 1 slope. So that means I go down 1, right 1, down 1, right 1. Then I can continue that on forever and ever in both directions. And I can easily see the solution to my system. It's this point right here. It is the point. It's over 1, down 2. Okay? So there's the solution to a system of equations. So let's take a look at a different one. So here's the next one. All right, so on this one, we're going to start on 1. So we're going to go on 1 on the y-axis. And then my slope is -2 over 1, so I go down 2 over 1, down 2 over 1. And I continue that forever if I wanted to, and then to go the other way, I'd go up 2 left 1. And obviously I can continue that forever as well in that direction if my plane went on forever. Okay, so on the second one, we're going to start at +5. So 1, 2, 3, 4, 5 right there. And as we can see, we see that the slope is a -1 over 1 again. Then we're going to go down 1, right 1. As we can see, this is kind of taking me away from my green line, so I'm going to go the other way. So that's up 1, left 1, up 1, left 1. Haven't hit my green line yet. Oop, we hit my green line, and then we pass it. So that's interesting. So we hit my green line at this point right here. So that is left 1, 2, 3, 4. And up 1, 2, 3, 4, 5, 6, 7, 8, 9. So the solution to this system is -4, 9. All right, I want you guys to go ahead and try these two problems, and we'll come back together on this problem right here.